Welcome to Part 4 of Control with Wireless.
My name is Eric, and I am the RTU Product Marketing Manager for the Remote Automation Solution division of Emerson. Some of the things that Curtis has been talking about, you can actually see our booth and Curtis's booth. You can see some of the wireless discrete control. On our booth, we actually have a 702 working with a signal from the ROC and opening a valve. We also have an actuator 4310, similar to 4320, that's opening and closing a valve. So all of that is in existence. We're using that today. It's out in the field, and you can see an example of that in our booth. About using wireless control in the ROC, as Terry had mentioned, a major partner of ours is very interested in finding about using the benefits of wireless control through the innovative PID Plus in the ROC control system. So we basically have been thinking about wireless for a while. We know wireless is Emerson's way to help differentiate us and bring improvement to our customers. We can decrease our overall installation, all of the good things you hear about wireless that we want to do. We want to actually expand that to include the control side. So also, as Terry mentioned earlier, wireless control might not be the best fit for something that needs an instantaneous reaction. But there are quite a few control loops out there, possible control loops that you could use the PID Plus and wireless control. Some of them would be different types of gas lift control, different types of injection, water and steam injection at the wellhead, any type of choke control, whereas normal non-automated choke valves are only adjusted once every 6 weeks, maybe once every 6 months. If you add some automation and you use the wireless control, you can actually make that a lot tighter and give much quicker response as opposed to what the customer is normally used to. And there's also some other type of variations around the pad. There's a gas temperature control application where the gases coming out of the ground are much warmer than they want to be to put in the pipeline, so you put it in a heat exchanger. You increase your residence time by way of a choke valve that allows you to bring the gas down to the proper temperature. So just a quick graphic where we are in the RTU and wireless. As you're probably most are aware, the RTU is a little bit different than the DCS systems. We are typically set up to be a low power, very rugged type of controller that's out there in the field, sitting there in the south part of Texas or the northern part in Siberia. We have to be able to withstand a large range of temperature. So it's important for us to basically have a controller that doesn't take a lot of power. And what we've discovered in the past with all of our wireless implementations is pulling the additional information back to the RTU is something that our customers really appreciate. It allows them to optimize the production at the well without adding additional cost. For us, we always say if you want to do wireless and you have a need for some type of control, you can use a wireless control module that goes into our RTU, or you could also hook it up with the gateway. You guys have seen some pictures of the gateways. That also works with our RTU. It's just an option to consider. So I mentioned gas lift control. Here's a possible scenario as a graphic here. I know that gas lift control is a possible application for wireless control. I'd be very interested in hearing from you guys out there in the audience if you think this is something that is to be considered. But the way this would work, obviously, you know, your gas, of course, would be going back into the well. And what we have here is we have a pictorial representation of a control valve with a wireless module to it. This would actually be receiving the signals from the RTU. So the PID control algorithm would be existing inside the RTU. This would be a type of application that does not need, like I said before, an instantaneous feedback. If you have the 8-second control, you can get your very quick execution of your calculation, and you can turn around and send the information back to the valve to allow your gas to be re-injected into the well. We have quite a few devices that we do have support for right now on the wireless side. These are just some of them here. They're all pretty much what you may be familiar with around the wellhead. They're all Emerson WirelessHART devices. As I mentioned earlier, we have the WirelessHART module that does go inside the RTU. Some of you may be familiar with the FB107, the ROC 800, the ControlWave Micro. They all exist with their version of the gateway and the IAC module, and that's something we're going to be testing when we start looking at using the PID program with our oil and gas partner. Just a quick graphic for you guys who didn't remember us from the first slide. Terry, this is the PID algorithm. It actually has been adopted. Terry worked with our group, and we have a version of this for implementation in the ROC controller. This will actually be rolled out into a testing scenario in the next few weeks or so, a few months or so at the Fisher Control Lab, and we'll be able to work with the wireless control on the ROC and make sure we have a lot of good information. So next year at this time, we'll be able to show you reams and reams of data. I don't have a lot more on this, except I would like to ask you, assuming that if you're coming from the oil and gas side and you are familiar with wired control at the wellhead, and you may be interested in wireless control, do any of you guys have any ideas, any thoughts, any suggestions? We're very interested in finding out what we can do and working with you guys.
Any oil and gas folks in here at all? What industries is everyone in? Get a sampling of industries. Mining? Okay. Chemical?
Life science.
Life science, chemical? How many of you have wireless? A couple folks that doesn't. Okay. How many of you are thinking about doing wireless control now that you've seen this presentation?
That's the tough one. I've always used it on like remote tanks or remote stuff, but I've never used it on control stuff. That's why I asked a lot of questions around it.
Yeah. So maybe the question is, how many of you have ROC or something remote? One. All right, step up.
It's going to be a user C application. Is it going to be a firmware update at some point as well, or all of it's user C?
Okay, so right now, the question was, would this type of control, the PID plus algorithm, be an additional user program that's added into the controller, or would actually be part of the base firmware? Right now, because we're still doing the testing, we want to make sure we're tweaking it all, we're doing it as a user program. But there is plan, of course, because proving the benefits of what we have and what we're doing in terms of the testing at the Fisher Lab, we'll probably be implementing it into our firmware in the future to make it easier, quicker, faster response. And if you're asking about user programs, you may be concerned about loading and stuff like that. So we're going to make sure that's not a problem. Provided that our customers are interested, I'm just kind of curious if you have an application that you may just be thinking in the back of your head for that.
We have a gas lift application in North Dakota that is very similar to what you showed. That might be a good customer, and also tank level control in Texas.
Great. Yeah, actually level control, temperature control, we see as a fantastic opportunity for PID plus wireless control. So if you'd be interested, maybe we can talk a little bit afterwards. Okay, great. Thank you. Anybody else?
So early in the presentation, you mentioned that really battery life was a function of your update rate. So if I have, I'm in the power industry, so there's power everywhere, but our main cost is really going to wire back to the I/O. So if I had a wireless transmitter and instead of using a battery, I had a SIG power source.
Because then the update rate of the wireless devices can go as fast as 1 second. Right now, if you go as fast as 1 second, though, you limit the size of a network. Right. Typically, if you have a 1 second update rate, you're going to have around 12 devices. If you have 2 second update rate, I think it's 25 devices. 4 second update rate is 50 devices, and more than 4 seconds, it's 100 devices on a gateway.
And I believe in the future we will have a gateway that can do more instruments faster. Right? At some point in the future we'll be able to write out those different conditions.
Is the gateway redoing?
Yes.
What happens if wireless control gateway fails?
It really depends upon the valve and the vendor. In the 4300 series, the discrete control, if there's a user configurable, user selectable range that says what do you want that valve to do if it drops off the network. The default action is nothing. It fails in last state. But if it goes off the network for a period of time, you can say I want that valve to fail open or I want that valve to fail close. It's up to you.
Does that apply for modulating valves also?
The modulating valve, yes, it's the same thing. You can do the same thing.
So they can hold last value.
Because that's their default. If you've got a digital set point coming in, it's not like the analog. And typically, if that digital set point doesn't change, it's going to maintain that last value.
Yeah, if the gateway fails and you're only using wireless measurements, but a wired valve, right? Then at that point, basically the PID is going to hold last output, unless you add logic that says on loss of communication from your measurement, I'd like to take special action, which you can do within the module.
So what do you recommend reading to try to persuade a customer to go with wireless control?
His book.
Well, yeah, we have this book called.
There's still really a lot of skeptics out there.
Yeah, no, I think if you look at the book, this Wireless Control Foundation, not to push the book, but it really reflects 10 years of work on control with wireless and examples, application examples, other things. We don't get a penny out of the book. All the royalties are donated to University of Connecticut, so to improve their control program. So we aren't pushing it to make money, but it is a good resource. There's a website that goes with it, and in each chapter of the book is a workshop. And so the solution to the workshop, you go to the website and there's a 10-minute YouTube video showing you the solution. So, you know, if you wanted to show someone, here's how you commission a device. Well, when you go to the website, you see Mark Nixon actually commissioning a device, going through Delta V, and in about 3 minutes, he's suddenly showing it on the display, right? So it shows how easy it is, and then there's demonstrations of wireless control with a wireless measurement, control with a wireless valve. So you get YouTube videos. So those are good things to sort of, if you have a skeptic, say, look at the YouTube video. This is real stuff here. So.
My favorite thing about the book is I haven't had to really answer a wireless instrumentation question since it came out. I just take a read the book. Because it answers literally every question about wireless that anyone could possibly have. I mean, I've gone through all of it. It covers it, soup to nuts, monitoring and control, how the wireless network works, everything. Right, so you can, use that as a reference guide for, interacting with customers or your management on proving to them that this is well-proven technology. When you have $300 billion, I mean, we've sold a lot of wireless instrumentation out there. A lot of customers are using it strictly for monitoring. Now we're on the leading edge of they can be used for control.
Are you worried about your job?
No, I have a new job.
Yeah. One chapter.
This is looking up. I have a new job.
Yeah, one chapter of the book is just dedicated to how to put PID Plus in your control system, a legacy control system we call it. So if you have a PLC, you have an older control system, you can put it in there. It's not a difficult thing to do.
What's the name of the book?
Wireless Control Foundation. It's at the ISA bookstore. Mm-hmm.
At some point in time, you're going to, as you're doing this, you're going to have to do your own engineering, processes of comparing your traditional way of doing it with this new one, and comparing the results you get from the old way of doing it with the new way of doing it in wireless. And it's gonna show it's easier to install, cost less, and is just as reliable and maybe more reliable than a wired 4 to 20 signal. Because a wired 4 to 20, you've got current loops, you've got things that change over time, you've got calibration, things that you've got to set and keep adjusting. In the digital mode, you don't have that. You also have redundant gateways and multiple paths. So in those kinds of terms, the reliability of the wireless infrastructure is probably better than a 4 to 20.
And it's very easy to configure a wireless device in Delta V. We actually, the confusion is your work practices. Oh, I've got to put in a scaling factor. Well, there is no scaling factor because there's no wire, right? It just works. There's no more questions. Thank you, everybody.
Okay. Thanks for coming.